Everybody, thank you for your kind attention. I know 19 videos is a lot to look at, but I really do think that's what this was necessary to get our arms around this chapter and basically cover it from every angle. So last slide, this will be brief. The power of a stats test, a statistical test, is the probability that the test will correctly reject a false null hypothesis. That's what we want to do. If there really is something out there, I want to reject the null. If it really is the case that that sedative reduces saccades, I want to see that as the researcher. If it really is the case that that meditators sleep more hours, I want to see that. I want to reject those null hypothesis. And the power is a probability. That is, the power is the probability that the test will identify that effect if it really exists. Now, how can I make it more likely that that'll happen? If I have a large enough sample size, I want a large sample size within reason. Now, I don't want to run 1,000 participants because that's time consuming and wasteful of their time. But nonetheless, I would like to have enough of a sample size to give myself a chance. You might remember this Martian business. If a Martian thought that men and women were of different heights, then the null hypothesis would be that they're of the same height, right? But if he failed to reject the null hypothesis that they're of the same height, in that case, he commits a mistake there. That's a type 2 error that I don't want to commit. So what's the solution? Go out there and get 25 men and 25 women and abduct them into the spaceship, and then you'll see that there probably is a couple inch difference in height as a rule. The alpha level. If the alpha level is set at 0.1, I make it more likely that I won't reject the null hypothesis. So if all things equal, I'd rather have it in 0.5. That might be better. Gives you a better chance to observe a sample mean that falls in that critical region than if it's set at 0.1, you might say. And conversely, all things equal with respect to power, one-tailed versus two-tailed tests make a difference. All things equal, if you have a one-tailed test and you correctly predict the direction, your power is higher because I'm using that 1.65, for example, instead of 1.96, etc. I got to tell you, on these last three items, these are sort of esoteric, branches, if you will. They're sort of things that would take a lot more time to develop properly. So I'm going to make you a pledge here on April something, whatever the heck it is, the 16th, is that I'll just ask a multiple choice question, and the multiple choice question will be on our test. What are the factors that affect power? And it'll be sample size, alpha level, and one-tailed versus two-tailed test. And then the option D will be all of the above, and it is all of the above. But I sure hope you can appreciate particularly sample size. If I got enough people, it helps. If I'm a Martian and I abduct only 3 men and 3 women, I got a chance to miss that difference. But if I abduct 25 men and 25 women into the spaceship, I'm probably going to correctly observe that there is apparently a 2 or 3 inch difference in height between men and women. And that would allow me to correctly reject the null hypothesis that there's no difference between men and women. So again, the question I'll ask is be exceedingly direct, just like a all of the above type question. But again, this definition, the power of a statistical test is the probability that the test will correctly reject a false null hypothesis, and the power is the probability that the test will identify a treatment if it really exists. And as the researcher, I want to identify that. I do not want to miss it. If it's really there, let's get it. Let's identify that thing. So that's the notion of power, and it's a really subtle endeavor. One thing I'll leave you with, can we look to investigate the number of participants that would presume to be needed to find an effect if there is one? And yes, we have tables that do that. And that's something that if you want to drop by sometime in the fall, we have a 2.5-hour graduate stats course that meets on Monday nights. And we do a lot of that by hand if you're ever interested. Well, again, thanks for listening. This has been a long Chapter 8, but I think we've kind of covered it all. You'll be pleasantly surprised that Chapter 9 will be shorter.